Okay, everybody, I want to welcome you to our virtual webinar. For those of you who may have joined our live session and were unable to actually hear or see anything that we were talking about, we wanted to take an opportunity to record this and send it out to you so you could at least get the content that was presented. So what we want to talk to you about today is really the genesis of a DevOps journey, how DevOps is kind of maybe taken hold or taken root in your environments and how it starts to grow. And then as you kind of start to grow more and more, how you actually need to, the value of leveraging things like Terraform and things like Vault to actually accelerate this transformational journey that you might be on. So let's meet Doug, right? You may have a Doug in your environment, and Doug's a DevOps engineer, and he really knows what he's doing, but Doug has some challenges. See, Doug has to be able to provision cloud resources reliably and repeatably because that's what's been asked by a couple different teams. Maybe it's the e-commerce team has come, or maybe it's the marketing team who said, hey, we have a couple applications. We want to be able to deploy them. We want to run it in AWS. And could you please provision all of these resources? And he gets a kind of a spec sheet. And so Doug has to be able to do this repeatably over and over and over again because it's just Doug. So Doug has this desire to not only just deploy it, but manage it across its life cycle, upgrades, maybe issues. Doug's really buying into this idea of immutable infrastructure. And so he wants to be able to just kind of create and destroy pretty much at will when it comes to supporting these teams. And again, he has multiple stakeholders in this. So not only does he have to adhere to the specs of the app owners, but he also has to adhere to some level of security standards and also has to keep up with documenting how he's deploying this and what's in the environment at any given point in time. And Doug doesn't want to use spreadsheets, and I don't blame Doug. It's hard to manage things with spreadsheets and bash scripts all the time. So Doug, he's a smart cookie. He goes out and he does a little googly search, and Doug finds this thing called Terraform. And so he is actually saying, hey, maybe this Terraform thing will actually work for me. And so he starts to utilize it. And Doug quickly finds out that it gives him the ability to write once, deploy multiple times. He's able to do it in an automated, repeatable fashion. He can do Terraform applies and everything goes out. He can make changes. He can even do a Terraform destroy and make sure that he cleans up his entire infrastructure that he's deployed. And not only that, because of the way that Terraform outputs everything into a state file, Doug actually is documenting his work as he goes over and over and over again. Doug makes a change, it updates the state file. He can query the state file, give a readout of everything that's in the environment. And so now Doug has built some level of continuous documentation, which is great. He's given a reliable way of deploying infrastructure to support the teams that he needs to support, and that's great also. And he's able to manage that life cycle. And so Doug is on top of the world. And this is why Doug is able to do what he does. This is around Terraform. Now, Terraform is really broken up into two major components. The first thing is the core. The core is really what instantiates the language, right? So when you say you want to learn Terraform, you're really learning the language, the declarative language in order to deploy infrastructure out. What Terraform Core does is it does all the interpolation. So when you use variables, it's able to kind of mix and match those things together. It also does all of the operational functions like doing if-then statements, doing for each statements, actually doing evaluations of operators. So the core does all of that work and manages all of the kind of the from operator into Terraform management. So that's really what the core is really great at. But then outside of the core, which interfaces what we call providers, the provider aspect of things is any entity can write a provider that then exposes their APIs in a way that can be translated from Terraform language into the API calls for that particular provider. So that means that I don't necessarily have to learn each and every single cloud platform or multiple different entities. I just have to learn how to write Terraform to access that provider. And with those providers, not only do we support some right out of the box, like the major cloud vendors for AWS and those types of things, but we also support it for things like GitHub and Kubernetes and Datadog. We have multiple ones all over the place, But this expands the ecosystem out to where it's not just that I deploy infrastructure, but I can update configurations. I can actually manage my entire GitHub inventory. So there's multiple different things that can be done in the context of these provider plugins. Now, here is a challenge: is Doug becomes a victim of his own success. Now, your Doug may be actually attached to a specific team. So Doug may be the SRE engineer for one app, but Doug's doing such a good job that other application teams start to come to Doug and say, hey, we would actually like to use what you're doing for our team. And so now there becomes some challenge of managing Terraform at scale. The first thing is how do I enforce a level of consistency when I have multiple deployments that I have to manage? How do I actually instantiate and meet the needs of different groups and actually scale my own individual work to actually be able to spread across multiple different stakeholders? On top of that, how do I bake security in? How do I make that happen automatically? And then from Doug's perspective is he wants to be able to scale consumption to a self-service model. Doug wants to be able to write once and then deploy across multiple organizations, multiple teams, multiple applications, so that he can actually have a higher level of leverage across a larger swath of his infrastructure that he's deploying. So in order to do this, we have to kind of look at all the players that are connected in what Doug is trying to do. So let's meet Gideon. Gideon is a developer that Doug has to support. So Gideon has some specific needs and desires within his framework. So Gideon wants to just be able to request resources and have them spun up, and that's it. He actually doesn't care anything about is it a scaling group? Is it just a single EC2 instance? Maybe it's some containers. Maybe he has a little bit of say in that. But for the most part, Gideon just wants to write code, hit commit in his Git repo, and then 30 minutes later get an email saying the builds are all done and here's a URL that you can actually go and look at it. He wants to have pre-configured stacks, right, that are ready to go for him at a moment's notice. On top of that, Gideon doesn't want to break his workflow. He does not want to jump out of his IDE and have to go to a UI or have to come back. He doesn't want to do any of those things. He wants to stay focused on what he's trying to accomplish. So at the end of the day, he is completely not concerned about how the infrastructure is set up. It is, in his mind, inconsequential outside of it just needs to be up and it just needs to be working in a way that is repeatable and that I understand. Now, there's a whole separate crew that Doug has to deal with. So let's meet Sarah. So Sarah is a part of the QA team that Doug must support. Now, QA is starting to change and take on different forms. This may be your continuous integration group, where they're actually building all the testing frameworks. And when Gideon commits code, they actually build all the tests and things that ensure the reliability of that code, and then it doesn't work across multiple different stacks and multiple different versions. And so this is what Sarah's group really kind of deals with and is tasked with understanding and managing. So for Sarah, she wants to be able to manipulate different infrastructure stacks that are pre-created, not necessarily create from scratch. She is usually testing multiple iterations of an application stack, maybe different versions, different libraries, maybe it's different minor revisions, but all those things are requiring small little changes to an overwhelming kind of similar stack. And on top of that, Sarah may know a little bit of Terraform, but she really hasn't fully dug in and is really writing her own stuff. She knows enough to understand what's going on under the covers and maybe suggest some changes, but she hasn't really come up to speed with the full-blown Terraform, and she may not really want to. She may need to just understand it enough to understand how it fits into her overall pipeline. But outside of that, she doesn't necessarily want to have to learn Terraform, but she still wants to consume the value of what Terraform provides. Now, let's meet Madison. Madison is a part of Doug's team. Doug got lucky. They brought in somebody just as talented as he is with his Madison. And so Madison is a stack builder just like Doug. And she supports the dev and the QA and the production teams. And so she wants to write all the Terraform code that all those teams that we just met, the Gideons and the Sarahs of the world, actually consume from. She's tasked with really building composable modules to make it easier to build different application stacks. So she's responsible for building all the different Legos that can then be stacked together to really reinvent an entire application. Maybe they want to move from virtual machines to containers, or maybe from just raw containers to Kubernetes, whatever it might be. Madison is tasked with building all the different composable units that can be stacked together that make those. So Madison is super deft at utilizing Terraform, understands how to build cloud infrastructure with it, understands modules. She knows it very well. Madison is hard to find. This is a very hard skill set to track down if it hasn't been built internally. And so with a combination of Madison and Doug, you need to take these two very, very talented individuals and be able to leverage them across a wide swath of consumers on this. Now, there are some other folks that you need to be aware of. You have folks in the operational team. So the operational teams aren't on the same team as Doug and Madison, who we met earlier. The operation teams are more concerned with the overall infrastructure, the overall application portfolio and ecosystem, and that everything is working together, and firewalls and all these different things. So they're maintaining that reliability and consistency reign supreme from one production deployment to the next. They also want to ensure that certain standards and best practices are adhered to maintain that repeatability and reliability. And they want to have a way of being able to audit and understand all the infrastructure that's deployed. Remember CMDBs? These are the folks that usually maintain those, and they have a very rigid, strict change management process that they have to follow in order to update the documentation and ensure that best practices and ensure that consistency is maintained. And so Doug has to work a little bit within the framework of these folks as he's deploying infrastructure into the cloud. Now, the next group of folks that we have to contend with is the security folks. Now, these folks, and we all have these in our infrastructure organizations, they want to ensure that deployments are secure as possible, and that actually security is baked into the deployment build process, so that from deployment to deployment, security is top of mind. They want to not only do that, but abstract any type of sensitive credentials away from these build processes. They don't want the Gideons of the world to have AWS API keys. They don't want the Madisons and the Dougs of the world to have any type of AWS keys. And so, I'm going to sneeze. Excuse me. They don't want anybody to have AWS keys. And so they want to abstract those types of things away. This is very challenging to do, especially with Terraform open source. In order to utilize and leverage Terraform open source effectively, you need to have credentials that it can leverage to do that. This is a challenge specifically for the security teams. And they want to have a level of auditability and governance and control for that infrastructure to ensure that best practices are met. So when you think about the full Hashi stack, and you think about all the different things that we do, we touch the networking stack with Console, and in the context of service-based networking, we tackle deployments, and actually be able to deploy massive scalable application components with Nomad. Then we deal with security with Vault, and then operations with Terraform. These are the two that we're going to talk about the most. So Terraform is primarily for operations, and it was designed from the ground up to meet a lot of these demands that you saw earlier, right? The ability to have automation through codification. We think about workflows, not technology. So not only with Terraform as an individual user, but all the way up to Terraform Cloud, with our ability for individual users, teams, and teams of teams to come together and actually collaborate to provision infrastructure. And also this ability of the open and extensible platform and format to be able to not only support AWS, but to support all the ecosystem that you may be using, Kubernetes, Datadog, Dynatrace, whatever it may be, that probably has a Terraform provider to actually manage the configuration of that. Now, Vault is our security infrastructure. And for Vault, it follows a very similar pattern. So Vault, now you have security as an API, meaning that I can kind of put a layer of transparency over my security and just make it just a part of calling an API within my build processes. I also have the ability now to be able to, with identity that's built into all these different platforms. AWS has identity built in, Okta, Nomad, all these different platforms have a way of validating identity. Wouldn't it be great if you could leverage baked in validated identity to be a broker to generate secure material, right? Not having to generate secure material beforehand and then hand it to these things kind of either in a trusted relationship or saying, okay, well, they have an identity, therefore they have access, but really being able to say they have identity, therefore they have the ability to generate credentials for a short amount of time. That's what Vault really kind of elevates, right? It can handle that starting point of static credentials, which we're all used to managing and maintaining, but take it one step further, making it actually more secure, where basically every type of access becomes very close to kind of a one-time PIN. Not exactly, but close. And because we integrate across multiple different things, databases, cloud platforms, certificates, all these different things, now you can just extend this out. And instead of having to create credentials for all these different types of data source access, you now can just say, this is a broker that gives you short-term limited access to it. And so when we look at all of these teams kind of together and how they fit across and all the different needs that they have, let's kind of talk about this. So for the development teams like Gideon, if you think about it, you have that API front end, right? Because they just want to like send an email, maybe submit a form, maybe submit a ticket, and then just get a response back. So an API front end for security and for provisioning is huge for the development team. They also want an ability to have application isolation. This is challenging when you're just dealing with open source because you don't have things like namespaces. You don't have things like workspaces where I can create a level of application isolation and make sure that that configuration is specific to that one development team, but that it doesn't trounce or trample on another development team that may need completely different requirements. For the testing team, they need the ability to have a level of variation on demand. So they need to be able to continually consume stacks of infrastructure and then modestly migrate it and update it. So they would be able to leverage Terraform Cloud's UI or Vault's UI to actually be able to go in and make changes and edit those things without necessarily needing to have a deep level coding understanding of specifically Terraform or specifically Vault. So they could consume it quickly. So for the development and the testing teams, this becomes a massive self-service because all of a sudden now for Madison and Doug, you have literally exponentially given them more leverage across all these teams. Because what Madison and Doug can do is they can really focus and maintain on those individual building blocks and publish those things as modules that the development or testing teams can actually consume without necessarily having to tap Doug or tap Madison on the shoulder and say, excuse me, could you please create a whole new stack for me? They could just say, oh, I just need to cobble these 15 different modules together and maybe put some variables in it to maybe scale it out or put it in different regions. But I just do a couple things. And because it's API driven, development teams may be able to say, well, I just need module X, Y, Z, and I need it here. And they never even have to talk to Doug. It just automatically happens, right? And all the credentials for it are managed remotely with Vault. So that just becomes a quick way of being able to consume this at scale without necessarily having to find 15 Madisons and 12 Dougs and have these massive teams just to support each individual application owner. From the operational perspective, you now have centralized control. So Terraform and Vault give you the ability for the enterprise perspective to have a level of centralized control. So manage secrets centrally, access them locally, deploy it out locally. And from a Terraform perspective, it's provision any and all resources through one single point. And so you have this idea of centralized control. You also have the ability to have credential isolation because you can actually consume Vault secrets in Terraform quickly, easily with the API-driven framework, and nobody actually has to touch those. You can even go as far as doing the on-demand credentials, and therefore those credentials literally could just be used every single time you build, and then they're destroyed afterwards. On top of that, because of the centralized state management, now the operational teams get an up-to-date CMDB all the time. They can literally query Terraform, parse through the JSON state files, and actually produce Visio diagrams. They could produce all kinds of up-to-date documentation just by consuming the JSON. So you could literally just have, show me my environment, and everything about it would just appear with just a little bit of effort. So from an operational perspective, this is great, because this is one of the main challenges with CMDBs right now is as soon as I update it, it is now out of date. And with utilizing Terraform and Vault, merely changing configuration updates all your documentation. So now documentation is just an artifact. It's just baked into the process. And from the security team, they love this idea of the combination of Terraform, Cloud, and Vault, because now they have a unified way of managing secrets access to a point where they could even go full-blown dynamic credential, and therefore there really is no such thing as a static secret. Everything about it is ephemeral in nature. They can leverage all the great rich data and metadata that's out there for cloud-based identity. Imagine no longer having to manage a large list of roles for machine entities that get spun up. You could literally just say, okay, well, this machine entity spins up. As a part of it spinning up, it's actually going to go generate API keys from Vault, and that gives it access to the different types of things. And those are time bound. There's all sorts of things you can do to make security baked in, but make it very transparent. And so security teams really gravitate towards this because of the ability to manage it. On top of that, with Terraform and Vault, we have this thing called Sentinel, which is basically a unified policy and governance engine that works in Vault and in Terraform Enterprise. And so what that allows you to be able to do is codify all of your security best practices, codify all of your operational best practices. Therefore, as Doug and Madison are writing these things, they can test it against these codified governance policies to ensure that they're meeting the up-to-date criteria best practices. It also means that Sarah's team can't accidentally create a security vulnerability because they made a change to a specific variable. It means that the Gideons of the world don't even have to think about security. Imagine that. Imagine you just remove that burden of security from the development teams, and it's just a matter of when they check in code, that just happens. Right? They get a level of feedback if something doesn't work, but for the most part, it's a completely transparent process. Security becomes baked in. That is a holy grail for continuous improvement, continuous delivery, continuous integration, all those things. They say bake security into the process. The combination of Vault and Terraform allow you to do that, giving you full-blown access, centralized in kind of the way that it works, with a baked-in level of security that everyone is on board with. The governance, the Sentinel policies, that's his code, meaning that your security postures are already published. Anytime you make a change, it just updates the documentation, right? And imagine the amount of time that you could give back to all these different teams just if documentation was just an artifact of doing your work. It wasn't something they had to do separate. Imagine a world where the development teams literally just say, here's my code, magic happens on the back end, and they can focus on writing amazing customer experiences, writing amazing applications, and are not bogged down with trying to figure out all the infrastructure components underneath it. Imagine the CI/CD testing teams being able to basically deploy at will, because they're able to ensure a level of governance, they're able to assure a level of security control, they're able to satisfy all the security team's requirements without having to go and having these meetings over and over and over again to validate, did we do this? Yes, did we not? Right? It just becomes baked in. All of this leads to an acceleration of being able to deliver on those strategic projects. Think about it. I absorb a company. If you're doing this, it becomes easier to absorb that company, because you just start codifying all the different aspects of that company, and then you drop it in, and now you can start to make change. You want to move to Kubernetes from your on-prem? If you're doing it this way, it becomes super easy. Security, baked in. Provisioning, baked in. Kubernetes deployments, baked in. Terraform can do that too, right? All of this allows all of these different teams to accelerate together. That is one of the number one things that companies are looking for. In fact, in COVID right now, I just saw a statistic the other day. 75% of the C-suite, CEOs, CIOs who are polled said that during this time, they are doubling down on their investment for digital transformation. These are foundational components of that digital transformation. My name's Steve Wilson. I really want to thank everyone for the time. I'm sorry that you weren't able to join the webinar before. I hope this has been helpful. If it has, please reach out to us. I would love to hear your feedback. Tweet me, whatever you want to do. We'll have all the obligatory social media plugs out everywhere. But really, I just want to thank everyone for their time to listen to this and to watch it. Have a great day, everyone.